Welcome back, everybody. We are going to do questions 11 through 14 on this one. And what we've got here, the first one says plot the points to create a rectangle, and what would the coordinates be of the other vertex. Now, looking at these points, I would have a little bit of trouble figuring out what the coordinates would be, but as soon as I start plotting this thing, I get a pretty clear picture pretty quickly of what this thing's going to look like. So I'm going to start plotting the points. You'll notice that I go over 0 and up 4. 1, 2, 3, 4. So over 0, up 4 puts a point like right. Let's make that guy red. Put that point right there. And then over 0, down 1 puts a point right about here. And then finally, if I count over 7, and down 1, 1, 2, and so that would put a point right here. And so if I'm trying to make a rectangle, then I would be looking for a point somewhere up in this area that would make my right angles and my slopes all the same. The slopes perpendicular and the slopes of opposite sides the same. And it looks like that if I went over 7 and up 4, that would be the point that I would be looking for my ordered pair of the rectangle. All right. Now in this next question, they told us that side AB in a rectangle is contained in the line of 1/4 x plus 2. So they're asking you what is the slope of the opposite side. Well, if this was a slope of 1/2 or 1/4, then the side opposite, in order to be a parallelogram, which a rectangle is, would have to have the same slope. So the slope of AB would have to be 1/4 as well. All right, the side opposite it would be 1/4. What is the slope of the side adjacent to AB? Well, remember that when we were just talking about sides opposite having the same slope. So now adjacent sides to AB, if this was A and B, sides adjacent in a rectangle would be 90 degrees. So that would be a perpendicular slope, which is the reciprocal slope with a change of sign. So either -4/1 or just -4 would be the way I'd write those slopes. Now the diagonal, these are just remembering the properties that we had for our quadrilaterals. All right, and so then in this one they're talking about the diagonals of a square. One diagonal has a slope of -3, and the slope of the other diagonal is. Now we have to remember that a square and a rhombus and actually a kite, in all of those shapes, the diagonals are perpendicular to one another. And so that's one of the properties we need to remember. And so and you're going to need to remember all the properties of our quadrilaterals, so that would be something I would be putting in my notes. And so if the diagonal is -3, so we would flip that slope over and change its sign, and so the other diagonal would have to have a slope of 1/3. Now the last one here, the rhombus math, it has these two ordered pairs. They want to find the length of AT. Well, MA has the length of whatever these two sides are. AT would be the length as it is, and one of our properties of a rhombus, just like a square, is that all the sides would be the same. So if I'm labeling this MATH, well, MA would have the same length as AT, so we have to find the length of, so MA, the length of MA will equal the length of AT, so let's find the length of MA using our distance formula, which we used earlier. Subtract the x's, so -4 minus -3 squared, plus subtracting our y's, 8 minus 3 squared, and if we simplify that, the length of MA, -4 plus 3 is -1 and squared, and 8 minus 3 would be 5 and squared. So simplifying that, it looks like I get 1 plus 25, or the length is the square root of 26. And so that would also be the length of AT. It would also be the length of any other side in this rhombus. All right, so this concludes our video for these examples. We will have more for the rest of the review soon.